Good evening, everyone. Am I audible to you all? Yes. Am I audible? Okay. So, today we'll be starting with the chapter, one of the important chapter from organic chemistry, that is hydrocarbons. Okay. So, what I'll be doing during this session is I'll be covering some basic concepts or basic parts from the chapter, that is hydrocarbons chapter, and then I'll be doing some important questions from this chapter. Okay, so let us start with the hydrocarbons chapter. Is the screen visible to everyone? Yes? Is the screen visible? Srushti? Okay. So, what are hydrocarbons? The name itself gives us the meaning of the name hydrocarbons. Okay, hydrocarbons means the compounds of hydrogen and carbon. Especially now we have studied the hydrocarbons in 10th standard only, the main hydrocarbons which are there for us. Okay, now in hydrocarbons we have different classification. We have classified the hydrocarbons in different categories. Okay, so now they are classified as alkanes, alkenes, alkynes and arenes. So first comes the alkanes. Okay, alkanes, then we have alkenes, then we have alkynes, and we have arenes. Okay, now what are alkanes? Alkanes means the hydrocarbons which are having single bonds between them. Okay, they are bonded together with a single bond. Those are the alkanes. They are also called as the saturated hydrocarbons. You all must have studied this in 10th standard. This was a basic carbon and its compounds chapter. These basic things were there in this that chapter. So alkanes are the saturated hydrocarbons having single bond. Okay. Now next is alkenes. Now what are alkenes? Alkenes are the unsaturated hydrocarbons. Unsaturated means they are having more than one bond. That is, they are having a double bond. Okay. So alkenes are the hydrocarbons having double bond. And next is alkynes. Now, what are alkynes? Alkynes are also unsaturated hydrocarbons having triple bonds between them. Okay, so these three alkanes, alkenes, and alkynes we are going to study in this chapter. Okay, basically, we will see the preparation of these three, like the how to prepare these alkanes, alkenes, alkynes and arenes. Then what are their physical properties, what are their chemical properties, what we can prepare from prepare using these compounds. Okay, so basically we will study about this in this chapter. Okay, now last is arenes. Now what are arenes? Arenes are the aromatic compounds. Okay, now most of the aromatic compounds, they are having ring structure. Okay, now what a ring structure? Ring structure means they are cyclic compounds. Cyclic compounds having double bonds in them. So we are going to also study the arenes, which are the cyclic compounds having double bonds in them. Okay, so those are arenes are also called as a aromatic compounds. Okay, so arene means also the aromatic compounds. So first we will start with the alkanes. Okay, so now what are alkanes? As I have told before, that alkanes are the compounds which are having single bond. Okay, hydrocarbons which are having single bond. Now let us take an example of this: CH3, CH2, CH3. Okay, this is also, this is a one type of alkane. Now which alkane is this? Now since we are having three carbons, okay, now we are having three carbons over here. So when we have three carbons in the alkane, we call that alkane as a propane. So this will be called as propane. If we have one carbon, we call that alkane as methane. If we have two carbons, we call it as ethane. So if we are having three carbons, we will call it as propane. Similarly, okay, if we are having four carbons, okay, if we are having four carbons, if we are having four carbons in a chain, we call it as butane. Okay, these are the simple common names of those alkanes. Okay, now one more thing we have to study in this concept, that the isomerism. Okay, isomerism in these compounds. Like in propane, we have seen that we can arrange the carbon and the hydrogens in straight manner. Okay, straight manner means what? CH3, then CH2, then CH3. Okay, but is there any other way to arrange this carbon and hydrogens? No, in propane we don't have any other way to arrange this. Okay, because if you try to put CH2, okay, below this CH3, if you try to put this CH3 below this CH2 also, then it will be the same. Okay, it will be the same means it will become a long chain only. If you try to put it below also, if you are trying to put the at the first carbon also, it will be straight chain. So here in the in case of propane, we can't form a chain compounds. Okay, but in butane we have this straight chain, that is CH3, CH2, CH2 and CH3, they are arranged in a straight manner. So we can write this compound in one more way also, that is we can write it like we can write three carbons, okay, in a straight chain this way. Okay, three carbons we can write this way. Okay, and one carbon which is left, that we can write here down. Okay, so we can write that carbon over here. Okay, that is the CH3 molecule. But now we have to check the valency also. Now we are having CH3 here, so carbon's valency is completed. Here we are having CH2. Okay, but here we are having one bond, here we are having one bond. Okay, and here with CH3 it's forming another bond. So we are already having three bonds. So here how many hydrogens are there? Two hydrogens are there. So already we're having three bonds. So how many hydrogens do we need here? We need only one hydrogen. That's why we have to put only one hydrogen over here. Okay, so here there is only one hydrogen and not two hydrogens. So this way we can arrange the butane. Okay, this way we can arrange the all the four carbons. So this is the second way of arranging the carbons, and this is also called as isobutane. Okay, this is called as isobutane. Yeah. So when we arrange the butane in this manner, okay, it will call as butane only according to the common name. But since it is arranged in this pattern, it will be called as isobutane. Okay. So this is the isomerism in alkanes. Now next we will see about the preparation. Now, like the way I have shown you all the butane isomerism, same way you have to do for pentane, hexane. Okay, so if the formula is given, what you have to do, you have to just write the uh, straight chain first, then you can see how many times you can arrange the compounds. Okay, how many times means how you can arrange the compounds in different ways. Like I have shown of butane. So butane, how we can arrange? We can write the three carbons and then we can write the methyl group. Also we can arrange the butane, the pentane, hexane in similar way, okay, by putting the groups, okay, according to the, making the branches of that compound. So that will be called as a branched group. Now next we are going to see the we are going to see the preparation of alkanes, okay. We are going to see the preparation of alkane. So first method we will see, that is from alkenes, okay. First method, that is from alkenes. Now we all know what are alkenes. Alkenes are the unsaturated compounds having double bond, okay. Now how to prepare alkanes from alkenes, okay. So now we are having, let us take one example of alkene, that is CH2 double bond CH2, okay. Which alkene is this? This is ethene. Alkene having the alkene which is having two carbons, okay. So alkenes which are having two carbons, it is called as ethene, because alkane with two carbon we call it ethane, so this will be ethene. So as a product, what we want, we want alkane as a product. So if we have alkene as ethene, what product we will get? Of course we will get the product as ethene, so it will be CH3, right? This will be product. Now we are preparing alkane. So from ethene we will prepare ethane, that is the alkane, right? So now from ethene we are getting ethane. So what are the changes that we can see over here in product? In product we can see that here there are two hydrogens, right? In CH2 here we have two hydrogens, and in ethane we are having one more hydrogens on each carbon. So one hydrogen is there on first carbon and another hydrogen is there on the second carbon. So we are having two hydrogens extra on the ethane, okay. So to have two hydrogens extra on ethane, what do we need to add here? We have to add two more hydrogens. So for that we are adding H2 molecule or H2 gas over here, so that we can have one hydrogen on each carbon on the ethane, okay. Now only adding of H2 is enough? No, okay. With that we have, what we have to do, we have to take help of a catalyst, okay. We have, because adding catalyst will speed up the reaction and product will form fast. So ethene plus hydrogen will also need the help of catalyst, that is the catalyst used are palladium, platinum or nickel. So these three catalysts are used. Three catalysts means any one catalyst you can use, either palladium, platinum or nickel. So any one of these catalysts you can use to form the ethene, okay. So this is the preparation from alkenes. Next we will see the preparation from alkyl halides. Preparation from alkyl halides. Now what are alkyl halides? Alkyl means what? Alkyl means the alkyl group, okay. And halides means what? All the halogens. So when the alkyl group and halogen they combines, we call it as alkyl halide. So let us take example of methyl chloride, okay. As an alkyl group we are taking methyl, that is CH3, and as a halogen we are taking chlorine, okay. So CH3Cl plus chlorine So how to so from this, which from this, now we are having one carbon over here. So since we are having one carbon, which ethane or which alkane will form here? We are having one carbon, so the alkane having one carbon will form, that is the methane. Okay, so we will have CH4 as a product here. So what we have to write, okay, what we have to combine with this alkyl halide, or what we have to write as a catalyst over here to get the CH4? Yeah, so what is the catalyst that we are using here? Hello, hello, can you all tell me which catalyst we can use here? Yes, anyone?
Nickel, palladium.
No. See, in first case we have prepared the alkane from alkene. Okay, and that time we have used the catalyst as palladium, nickel, platinum. So it's not necessary that we will use the same catalyst when you are using different method. Okay, so second way, we are preparing the alkane from alkyl halide. So that time we have to use the different reagent or catalyst. So here also we will add hydrogen gas, that is H2, and in here we will use zinc. Okay, zinc and H plus, we will use here zinc and H plus. Okay, zinc as a metal catalyst and hydrogen ion. Okay, so how we will get CH4 over here? This H plus which is there, okay, it will combine with the CH3 over here, and this Cl, okay, this Cl will go with the H and it will form HCl. Okay, the Cl which is there, it will go with the hydrogen and it will form HCl, and we will have one more H over here, which is combining with CH3, it will form CH4, that is the alkane. So this way we can prepare a alkane from the alkene. Okay, now there are too many methods, or there are so many methods that we can prepare the alkane from any other this reagents or molecules. But in this class we can't discuss everything because we have a whole hydrocarbon chapter to discuss, so we will take some basic points from this. Okay, so next I will go to the physical properties. Okay, so next is the physical properties of alkanes. So what are the physical properties? Physical properties means the appearance and the how the compound shows the boiling point, melting point. These are the physical properties of any compounds. So now what are the physical properties of alkanes? Now alkanes which are there, okay, now you all must have studied in the lab, or you all must have done some experiments also in the lab, regarding the physical properties like finding the boiling point, then all other experiments. Okay, but what we have studied here in this part of alkane is the forces which are there. Okay, so as we go higher and higher, like first we are having alkane having one carbon. Then we are having two carbons, three carbons, four carbons. Okay, so the alkane which are having one carbon, they are called as lower 1 2 3 4, they are lower this lower alkenes. Then we are having more than 4, then more than that, they are called as higher alkenes. Okay, so in lower alkanes, the van der Waals forces, or the forces which are, due to which the carbons are bonded to each other, are weak. And in higher alkanes, the van der Waals forces are strong, or they are, very very strong, that they can't, they can't be easily they can't be easily broken. The forces which are there between the carbons, you can't easily break them, the bonds between them. Okay, so why the forces are stronger between them? Because they are having van der Waals forces, and these van der Waals forces are strong because of the molecular masses. Okay, molecular masses means what? As we go higher and higher, as we go higher and higher, the number of carbons will increase. So as the number of carbon will increase, hydrogens will also increase, and as both the hydrocarbons, they are increasing, the molecular mass will also increase, and this increase in molecular mass will lead to the van der Waals increase in van der Waals forces, and this increase in van der Waals forces is responsible for them to, they meaning they are held together by these forces. Okay, so they are held together strongly. So this is one of the main physical property, that is the van der Waals forces. Now next physical properties is their boiling point in straight chain, then ring. Okay, straight chain and ring structure. Okay, straight chain or ring, you can say first, before ring you can say a branched structure. Okay, straight chain and branched structure. Okay, straight chain and branch. So what we can see, in physical properties of this alkanes, that when we are having straight chain, okay, let us take one example over here. Let us take the example of pentane. So we are having pentane means how many carbons? 5 carbons. So we are having CH3, CH2, CH2, CH2 and CH3. This is the straight chain pentane. Okay, now if you want to find the boiling point of this pentane, which is a straight chain, okay, it will have a higher value than its branch chain. Now what will be the branch chain for this pentane? Branch chain will be having CH3, CH, CH3, CH2 and CH3. Okay, now see, in this first compound we are having how many carbons? 1 2 3 4 5. In also the second compound, we are having 1, 2, 3, 4, 5. So both are pentane. Okay. So first one is straight chain and second one is branched. So here we are having in first carbon, in first pentane, what we are having? All the carbons in one chain, and in second we are having one carbon attached to the straight chain, one of the straight chain carbon. Okay. Now the in physical properties, the what is the concept of boiling point between these two? The concept of boiling point is that the boiling point of straight chain alkanes is more than the boiling point of branched alkanes. Okay, the straight chain alkanes boiling point is more than the branch chain alkanes. Now why is it the branch chain alkanes, they are having lower boiling point and the straight chain are having the higher boiling point? Okay, now we will see what is the reason. So see, as branching increases, okay, as we do branching or as we try to put the groups, okay, along to the straight chain, any of the straight chain carbons. And if you increase the branching, what happens is the surface area which is there, it decreases. Okay, surface area which is there, okay, within this is decreasing. And when you are having straight chain alkanes, the surface area is already increased, okay, and this is decreased. Okay, this is less than the straight chain alkane. Now as the surface area is decreasing, the forces which are there, okay, as we have more surface area, the carbons or the hydrocarbons which are there, they are bounded to each other by very strong forces. But as we are having the surface area getting reduced or surface area is becoming smaller, then the van der Waals forces are not that stronger, okay, and area is also smaller. So to break that or to dissociate that, we need we are not, we should not have a more stronger forces. So to break the compounds which are held together by stronger forces, we need to apply more energy or more heat. Okay, so in this first case we are having the carbons in straight chain. So when we are having the carbons in straight chain, we need to apply more and more energy. So as we need to apply more energy, the boiling point or the heat energy which is there, the boiling point will be more. To boil or to dissociate this to break the bond, we need more energy. So in first case, the boiling point will be more. But in second case, where we have branch structure, since it is, the surface area is increased, we do not need more energy. Okay, we require a little lesser energy than the straight chain alkanes to break this bond. Okay, so this is the physical properties concept. So next what we are going to see is the chemical properties. Okay, now in physical properties we don't have much in the alkanes. So question, if they are coming, they will come on this concepts only, the boiling point concept, the van der Waals force concept. Okay, so you should understand the concept first, and then you can apply it on any of the compounds, so you will not get confused during exam. Okay, so next is the chemical properties. Now, what are chemical properties? Chemical properties means the properties in which you are the chemical bonding is involved. Okay. Now, chemical properties basically means the reactions of the alkane, how they react with other molecular gases. So, here we will see one reaction, that is halogenation. Okay. Now, what is halogenation? Halogenation means you are adding a halogen. So if we are having methane, that is CH4, and if you add Cl2, okay, Cl2, that is a chlorine gas, in presence of light, H nu, then what you will get? We will get a alkyl halide. Okay, we will get a alkyl halide plus HCl. Now how we got this? When we combine Cl2 with CH4, one of the Cl will get combined with this CH3. Okay, we are having CH4, so one of the H will go, and in the place of this H, Cl will go and combine, and that H which is eliminated will combine with the remaining Cl here, and it will form HCl. So we will get CH3 Cl plus HCl. This is the alkyl halide. So this is one of the chemical property of alkane. Okay, yeah. So next we will see about the alkenes. Okay, now alkenes, we are having many other parts also, but in this class, since it is only 1 hour class and we have to solve the questions also, so we will not be able to cover those parts. So we will mostly will be doing in the next session or the other sessions of this community. Okay, so Next we will see about the alkenes. Now, what are alkenes? Alkenes are the compounds which are having double bonds. Okay. Now, how to, like, in alkanes we have seen the preparation of alkane. Now, alkenes also we will see the preparation first. Okay. So, how to prepare alkane? Also, we are having nomenclature in alkenes, but those are the basic parts that you will know, because you all will understand. Okay, that's why I'm just going to the direct the preparation. So first is from alkynes. Okay, to prepare alkenes from alkynes. Now, what are alkynes? Alkynes are the hydrocarbons having triple bonds. So, which alkyne we will take? We will take directly as an example this alkyne. Okay. So, this is what? This is ethyne. Ethyne. Now, in previous case, what we have seen, that how to prepare alkane from alkene. Okay, so alkene we have prepared alkane. So here from alkyne we want alkene. Okay, so what is the formula for alkene? Or here we have ethyne, no? So since we are having ethyne as a product, we will get ethene. So we will get CH2, that is ethene. Okay. Now let us check how we got this product. Okay, what we have to add here. So since here we are having how many hydrogens? One hydrogen to each carbon. And in product side, what we have seen, that there are two hydrogens to each carbon. Okay, so what we have to add here to get this ethene? This is ethene, right? Yeah. So what we have to add here to get the ethene? So since there are two hydrogens over here, we have to add hydrogen molecule, that is H2. And same we have to add like previous, palladium, platinum and nickel. Okay. So to prepare alkenes and alkynes from to prepare alkane from alkenes, and to prepare alkenes from alkynes, we can add the same catalyst, that is palladium, platinum or nickel. Okay, so here we can add the same catalyst and we can carry out the reaction, because it's almost the same. uh, Only the bonds are different, like we are having double bond and triple bond. Okay, so here also we can do the same thing, that is we can add palladium, platinum, nickel as a catalyst, any one catalyst, and we can add hydrogen gas. So this was about the preparation. Then physical properties are almost similar, like no other, extra points are there in the physical properties of this. So here we will, one more thing that is important thing we will see here, that is a geometrical isomerism. Now you all must be aware what are isomers. Okay, what are isomers? Isomers are the compounds in which the formula is same, the molecular formula is same, but the structures are different. The way the compounds, the way the atoms arranged, the way is different. Okay, so here we will see about the geometrical isomerism. So let's take an example of but 2 in. Okay, so what is the formula for but 2 in? We in no like in normal way we can write it as CH3 CH double bond CH and CH3. Okay, we can write it in this way. Okay, but 2 in. But we can also write this compound in two ways, that is using the geometrical isomerism. Okay, means the geometry of the compound will differ. Okay, so now what is a geometrical isomerism? If we are having single bond, no, we can rotate the single bond in any way, that we have studied in the this in alkanes part, that is Sohos and Newman projection, that I couldn't cover here because of the less time. But in that projections we have seen that when we are having single bonds we can rotate them anyhow, but when we are having double bonds we can't rotate them. Okay, so see here we are having double bond, so we can't rotate this double bond. Okay, so we have to rotate the compound by this single bonds only. So by rotating the single bonds, how we can write the compound, that we will see in this geometrical isomerism. Okay, so first we will see how to write this in one way, that is we can write CH3 C double bond CH3. Okay, now what is remained? Now this CH3 I have written here, this C I have written here, double bond, then here also C, and this CH3 I have written. Okay, because it is attached to this C is also attached to CH3. What is left now? The hydrogens for these two carbons, they are left. So we can write those hydrogens over here. Okay, yeah, now this is correct. So this is the correct way of writing. Now see, what we have done is we have written CH3 over here and here. Okay, so now CH3 they are to the same sides of these carbons. Okay, these two CH3 which are there, they are at the same sides of the two carbons. And how we can write this in another way? We can write this as CH3 C double bond C and CH3. Okay, and here we can write H. So both the ways it's the same compound, that is but but in case of geometry they both are different. So here in first case we can see that CH3 is attached to carbon and that carbon is also attached to CH3, and both the CH3 are at one side. Okay, and here in second case what we can see is both the CH3 are at opposite side. So in first case we call this as cis isomer. Okay, this is called as cis isomer, and when they are at opposite sides we call it as trans isomer. Okay, so these are the two isomers or the two geometrical isomers shown by the alkenes. Okay, so we are having the examples also in this, but this is a general example. Okay, yeah. So this is about the geometrical isomerism in alkenes. Now what we'll do now, I know that there are other parts also that we have to cover, but since there is a less time we will just take the questions from this chapter and then we will solve those questions. Okay, so rest we can do in the other session. So we will start solving the questions here. So I have a question bank or worksheet over here. Okay, is it visible? Can you all see the questions? Yes. Can you all see the questions? Okay. Any difficulty till here? You all understood what I have taught? Okay. So the first question is write the IUPAC names of the following compounds. Okay. Now you all know how to write the IUPAC names or IUPAC names. So we will see the first compound. Okay. So I will write the first compound. This is the first compound, right? Yeah, this is the first compound. I will also write the second compound. Okay, this is the second compound. Now, how to name the first compound? Now, for naming, what is the first rule that comes to our mind, or the first rule according to IUPAC? The first rule is that you have to count the number of carbons. Okay, so now how many number of carbons do we have in a straight chain? We have one, two, three, four, 5 carbons. Okay, we have 5 carbons. And next, what we have to see? We have to see the substituents which are attached to the chain. So now, since this is a straight chain, the carbon chain is a straight chain. Which are the substituents that are attached to the straight chain? Only one, bromine, that is Br. Br is attached to the straight chain, to the middle carbon which is there. Okay, now the next thing that you have to do is the numbering. Okay, now numbering we have to do. Okay, while numbering, what comes to your mind is to which group we should give the priority. According to priority we do the numbering. So we are having here CH2, CH2 and CH3 all are in straight chain. But what differs here is the double bond, okay, which is there at this carbon. So we can do the numbering from this side or this side. But here, where we can do the numbering, we can do the numbering from the left side, okay, because when you are numbering from the left side, the lowest number, that is the here one number, that will come at the carbon which is having double bond. And if you try to do numbering from the right hand side, then the for double bond, this carbon is having double bond here, right? So this carbon will get the high number. So what we have to see is the group which is having the priority should get as much as lowest number as possible. Okay, so here we don't have any other groups like functional groups over here. We just have bromine, but before bromine priority is given to the double bond. Okay, so we can write here, from here we can start numbering, that is 1, 2, 3, 4, 5. Okay, now this is the 5 carbon chain, so the name will be pentane. Okay, but since we are having double bond, it will be pentene. Okay, double bond at first carbon, so it will be pentene. But before that we are having substituent, so we have to write the substituent first. So how you will write the substituent? We will write it as, since it is at third carbon, so since the bromine, the substituent is at third carbon, we will write 3 bromo. Okay, 3 bromo pent. Why pent? Because we are having 5 carbons. So because we are having 5 carbons, we will write it as pent. Okay, it is the double bond which is there, it is at first carbon, so we can write it as pent 1 in. Okay, but if the number, meaning the if the one number is there, or if the double bond or the triple bond it is at first carbon, then if you are now not writing also no one number, it's all fine. Okay, but the double bond, if the double bond is at second number or second position, that you have to write the number, or you have to specify the number. If double bond is at second position, at third position, or more than that position, then you have to specify the number. So here also I will write just the number, but no need to write the number, it is also fine. So it will be pent 1. Since it is a double bond, it will be in. Okay, so the name of the first will be 3 bromo pent 1 in. Okay, now why 3 bromo? Because the substituent is at third position and priority is given to the double bond, so that's why we are numbering from here. And the group which we are giving priority will come as a suffix. Suffix means the suffix is the name by which the name of the compound ends. So it will be 3 bromo pent 1 in. Okay, is it clear? This was the basic or the easy one. Okay, now second we are having the this compound. Okay, so this is benzene. Okay, the hexagonal ring with the 3 double bonds is called as benzene. Now what is attached to benzene? We are having OH group and CH3 group. Okay, now how you will name this? Now we know that when we are having OH group attached to the benzene ring, the name is phenol. Okay, the name of that group is phenol. Now, which substituent is attached to this group? CH3, which is a methyl group, is attached. Now, here also from where we will start numbering, we will start the numbering which is, having more priority. So, here OH is having more priority, so we will number from here. So, this will get one number and this will get two number. So, the name of this compound will be, since this is a two number, that is the second position, it acts as a substituent. So, it will be 2 methyl phenol. Okay, the name of this compound will be 2-methyl phenol. Phenol is the suffix because that group, the main group is phenol. Then substituent is at second position. So that's why we have written 2-methyl phenol. Okay. Now next we will see the question. That is the second question. Draw cis and trans structures for hex 2 in, and which will have the higher boiling point and why. Okay. So we will write the cis and trans structure for hex 2 in. Now hex 2 in, first I will write the normal structure for hex 2 in. Okay. Now hex means what? How many carbons should we have? We should have 6 carbon. So I'll write 6 carbons. 1, 2, 3, 4, 5, 6. Okay. Hex means 6 carbons. Now 2 in means what? 2 in means double bond is at second position. So this is first position, this is second. So double bond will be here. Okay. Now we will write rest all carbons. Here we will have CH3. Then here we are having H. Then here CH. Then here CH2, CH2 and CH3. This is hex 2 in. Okay. Now how to write this in the previous manner that we have seen in this. Okay, while explaining the concept, I have shown the cis and trans isomer. So how to write in this in that way? We can write this like CH3. Okay, then here C, this double bond over here. Okay, so we can write this in this manner. Okay, so you see, we are having CH3, then C, then H attached to that C, then again here C, then H attached, and the rest group is attached over here. Okay, so we can write it in this way. That is the, now which is this isomer? This is the trans isomer, because we are having one group here and another group over here. Okay, opposite side. So this is the trans isomer. Then next we will write the another isomer, that is the cis isomer. So we can write this CH3 C, double bond C, then CH2 CH2 and CH3, and here we can write hydrogens, both the hydrogens. Okay, so this is trans isomer and this is the cis isomer. Okay. Now we are having the alkyl groups attached to the same sites over here. So we call it as cis isomer. And we are having alkyl groups attached to the different sites over here. So we call it as trans isomer. Now we are having one more question also in that, that is which isomer will have higher boiling point and why. Okay, now these are arranged in the trans isomer, they are arranged in the opposite manner. Okay, they are arranged in the opposite way. So here there won't be much dipole moment. Now what is dipole moment? Dipole moment is the, charge separation, or the when you are having polar compounds, we are having charge separation. So one atom will be having positive and other will be having negative. So since they are having opposite charges, it will be the charge separation between them, meaning the positive and negative charge which are there, there will be there will be a difference between those charges. So that is called as dipole moment. So when you are having the alkyl groups attached oppositely, okay, here like this, in opposite manner, that time the dipole moment or the charge which is there, it is not that much charge, because it gets cancelled out when it is oppositely, when they are present opposite in opposite manner. Okay, but when we are having them at a same side, that time they are not having that dipole, they are having a dipole moment, or the dipole interactions between them. And what are these dipole interactions? Those are the forces. Okay, the forces through which they are attached or attracted to each other. Now boiling points means what? The energy which is required to break the bonds, right? So when you are having higher dipole moment, what happens is the bonds, the compounds or the atoms are bounded to each other with great force, with much force. Okay, so when they are attracted or attached to each other with much force, that time it is difficult to break their bond. Okay, that time if it is difficult to break their bond, then the force or the energy required will be higher energy. So that's why the cis isomer will be having the more boiling point. So higher energy means more boiling point. Okay, yeah. So next question we will see now. Next question is explain why following systems are not aromatic. Okay, now since we were not having that much of time, we didn't cover the part of the aromaticity. Okay, but in question I will explain you what is aromaticity. Okay, now this question is based on aromaticity. Now what is aromaticity? Aromaticity is defined by Huckel's rule. Okay, Huckel is the name of the scientist, and aromaticity is defined by that rule. What the Huckel's rule is saying, it is Huckel's rule have given one formula, that is 4n plus 2 is equal to pi electrons. Okay, 4n plus 2 is equal to pi electrons. Now what is this n? N is the integer. Okay, n is the integer that can be from 0 to 0, 1, 2, 3. That is any integer. Okay, so n can be integer, and pi electrons means what? The electrons which are present in the compound. Like when we are having double bond, that means we say that we are having a pi electrons. So now, what Huckel rule says, that if any compound is following, or if it is satisfying the Huckel's rule, then the compound is aromatic. Okay, if any cyclic compound is satisfying the Huckel's rule or fulfilling the Huckel's rule, then it is called as aromatic compound. Now, in question, which two structures are given? These two structures. So I'll draw those structures over here. So first structure is this. Yeah, and here we are having double bonds. Okay, and second structure is this structure. Okay, so second one is this structure. So here we are having double bonds here. Okay, so yeah, this. So now we have to see if these two compounds are satisfying the Huckel's rule or not. So in first case, let us try to write the this formula over here. Okay, that is 4n plus 2. 4n plus 2 is equal to pi electron. Okay, now here, what is the what are the number of pi electrons we have? We have two bonds. We have two double bonds. Okay, so one double bond means how many one bond means how many electrons? One bond means two electrons. So since we are having two bonds here, we are having 4 pi electrons. So we can write this as 4n plus 2 is equal to 4 pi electrons. Okay, now since we are having 4 here, we can write this as 4n is equal to 4 minus 2. Okay, this is a simple mathematics calculation. 4n is equal to 4 minus 2. This 2 we have taken on the other side and we have subtracted the 2 from this 4. So we will get n is equal to, now 4 minus 2 is 2. So 2 by this 4 will come down. So it will be 2 divided by 4. So the answer we will get as 1 by 2. Okay, now the answer is 1 by 2. Now we got this answer as a fraction and not as an integer. So this is not following the Huckel's rule. Okay, this is not following the Huckel's rule, and since it's not following the Huckel's rule, the first compound we say that it is non-aromatic. It's not aromatic. Okay, so when they ask why it is not aromatic, then you have to use this formula and you have to show that it's not following the Huckel's rule, so it's non-aromatic. Same way you have to do with the second one. Okay, second one is having how many pi electrons? It's having 4 bonds. Since it's having 1, 2, 3, 4 bonds, when you use 4n plus 2 rule, that is 4n plus 2 is equal to pi electrons. Okay, that time you will get how many pi electrons are there? 4n plus 2 is equal to 1, 2, 3, 4, 5, 6, 7, 8 pi electrons. So there will be 8 pi electrons. So same way you have to do. You have to do 4n is equal to this 2 you have to take on the other side. It will be 8 minus 2. So 4n will be equal to 8 minus 2 is 6. So it will be 6. Okay, so n will be equal to 6 by 4. This 4 will come down, so it will be 2 2s are 4, 2 3s are 6, 3 by 2. So also this answer will not come in integer and it will come in fraction. So that's why we can say that second compound is also non aromatic. Okay, so this is the reason for their non aromaticity. Okay, so when the question they ask like why it is non-aromatic, you have to show this rule and you have to give the answer. The next question that we are having is complete the following reaction. Okay. First reaction that we are having is, I'll write it here. Okay. So this reaction we have. Now, which reaction is this? This is one of the very important reaction from the hydrocarbons chapter. That is the Markovnikov's and anti-Markovnikov's rule. Okay, reaction involving this rule. So now we are having this alkene or the unsaturated hydrocarbon, and to that we are adding HBr. Okay, now we have two reactions over here, and anti-Markovnikov. Now what is Markovnikov rule? In Markovnikov rule, what we do? we when you're having HBr or any halogen halide, okay, any hydrogen halide we are having like HBr, HCl. So what we do in Markovnikov rule, okay, we're having this, right? So this H is having positive charge and this Br is having negative charge. So H and Br, they will go here, they will go to the these two carbons which are having the double bond, okay. Now but we don't know where they will go, like where exactly they will go, where the H will go and where the Br will go. So the Markovnikov rule states that the carbons which are having the lowest number of hydrogen, okay, the carbon which is having lowest number of hydrogen, to that carbon this Br will join, and the carbon which is having the highest number of hydrogens, to that carbon the H will join, okay. So what product we will get? We will get the product as CH3 CH, and this Br will be joining here, so we will get Br here and CH3, okay. So this is the product that we are getting by the Markovnikov's rule. Now we have the second rule, that is anti-Markovnikov. Now in anti-Markovnikov, what will differ? The only the presence of peroxide will differ. So here on this arrow, the presence of peroxide will be given. Okay, so in for exam, if they ask the reaction involving this HBr, and if they give peroxide, then you have to use the rule as anti-Markovnikov rule. And what is anti-Markovnikov rule? Anti-Markovnikov rule will be the what we are putting now, that is we are putting H to this and Br to the carbon having low number of hydrogen. So anti-Markovnikov rule will be the opposite rule, okay, in which the hydrogen will go to the carbon having low number of hydrogen, and the bromine which is there, bromine will go to the carbon having more number of hydrogen. So anti-Markovnikov is exactly opposite to the Markovnikov's rule, okay. So but when you have to apply anti-Markovnikov's rule, only when there is peroxide present here, okay, here there will be peroxide present, that time only you have to use the anti-Markovnikov rule. Otherwise when there is just HBr, you have to use the Markovnikov rule. Is it clear everyone? Yes.
Yes, miss.
Okay, great. So one more reaction is given here, that is this reaction is alkyl halide, that is ethyl chloride plus alcoholic KOH. So directly I will tell you the product of the reaction, that when you add this to alcoholic KOH, you will get the alkene, that is here we are having two carbons, so you will get ethene as a product, okay. So reactions you can do on your own when you study the reactions, because there are simple reactions are there for you all, the preparation of hydrocarbons and chemical reactions of hydrocarbons, okay. Now next is the increasing order of boiling points for the following. Write the increasing order of boiling points for the following, this we will see, okay. So first is neopentane, then is n-pentane, then we have isopentane. What is neopentane? Neopentane means the hydrocarbon having 5 carbons, okay, in very branched manner, okay, in this manner. Neo means this plus sign, okay, it's forming in this manner. So this is neopentane. Next we have isopentane. Isopentane means this, okay. This is isopentane when you have having the group attached to meaning the group will be attached below the one of the straight chain carbon, okay, like this. And third we are having n pentane. N-pentane means the hydrocarbon having the straight chain. Okay, straight chain means all the carbons they are arranged in the straight chain. Now what is asked, write the following compounds in their increasing boiling point order. Now we have discussed this concept, no, while in the beginning when we were studying the physical properties of alkenes. So what we have discussed in that, as the branching increases, boiling point will decrease. Okay, when we increase the branching, boiling point will decrease. So here, where we can see the more branching, we can see the more branching in this neopentane. Okay, this is neopentane. So here there is more branching, here there is less branching, that is isopentane. And here there is no branching, all are in a straight chain, that is n pentane. All are in a straight chain. Now see, in neopentane we have more branching, so the boiling point will be very less as compared to two other alkanes. So here the neopentane boiling point is less. Okay, after that the boiling point will be higher, more than neopentane. The higher boiling point will be of isopentane, because here also there is branching but not as much as neopentane. So the lowest boiling point will be of neopentane, then we will have isopentane, and the highest boiling point we will have of n-pentane, because here there is a straight chain. Okay, there is a straight chain, and because of the straight chain we are having the more surface area or more area of contact, then the van der Waals forces increases, and if the van der Waals forces increases, then uh, the attraction, or it is very difficult to break their bond. So since it is difficult to break the bond, the energy which is required to break the bond will be higher. Okay, so since the energy is required higher, the boiling point or the heat that we are giving will be higher. So this is the concept that you have to apply when this type of question will come. Okay, now yeah, so now since the time is up, we will quickly discuss about the questions that can come for the exam. Okay, for your last exam. So what is there in this chapter? This chapter is basically about the hydrocarbons, that is alkanes, alkenes, alkynes and arenes. Okay, so now from alkanes part, what are the things that can come for the exam? Any one preparation can come, then this type of questions like on physical properties, how the the series will be given, and they will ask you to write the increasing or decreasing order according to their boiling point and give the reason why it is happening like that. Okay, then any one chemical reaction can come in the form of reaction. Then the iso this conformations can come, Sawhorse, Newman conformations. Okay, those are also important. Then in from alkenes also reactions can come, preparation of alkenes, then the physical properties, physical properties same as alkenes, not much difference over there. Then chemical properties can also come, then geometrical isomerism, that is also important, so from that also questions might come. Okay, then from alkynes or same things, that is preparation, physical properties, or um, this chemical properties, that is a chemical reaction. So what you have to remember, no, what is common in some of the reactions that you have to remember, and how it is taking place, like how the electrophilic substitution, nucleophilic substitutions. Okay, this type of meaning, if you understand one concept, no, then it will be easy for you to apply that concept for all the reactions. So you can study that and you can apply that. And also, and last part is arenes. Arenes means aromatic compounds. So aromatic compounds also, what you have to study the this how to prepare the arenes or aromatic compounds, and how to go about their physical properties, and also the chemical properties, that is chemical reactions. And main thing is the Huckel's rule, that is the aromaticity. Okay, that is also very important from arenes. So you should know how to find the how to know that the compound is aromatic or non-aromatic. Okay, some of the main important reactions that you have to study from this chapter, no, name reactions like Wood's reaction, then this anti Markovnikov's rule, then this Friedel-Crafts alkylation, Friedel-Crafts acylation, ozonalysis. So this type of reactions you can learn from this chapter. Okay, so these are the main reactions. Okay, so we will wind up now. Thank you for watching all this. Okay, I hope you all understood the what I have taught today. So if you understood, please say yes. Okay, yeah. So we will have a next session during some other time. So thank you so much for watching, and we will wind up with this. Okay, you can always ask the group of the admins. Okay, if you need any help or something, we are always, the Bodhi Academy is always there to help you. Okay, yeah. Thank you.